Yeah, good afternoon, everybody. And I have to start with a minor correction. So the Industry 4.0 was not started by the German government. So Industry 4.0 was started by, initiated by a group of industrial companies together with Achatz. Achatz is the organization of the German as consulting, basically German science is consulting the German government, and now the German government is adopting the initiative. So as we feel we address the right thing, and obviously we have a chance to be successful. I think it doesn't fit 100% right. It's a little high, but it may work. Okay, what I intend to talk about is basically Industry 4.0, and many people are calling it the fourth industrial revolution. I like more to say it's an important step to a digital enterprise. And it was said that I work for Thyssenkrupp, and just to make a short introduction of Thyssenkrupp. Okay, so I work for Thyssenkrupp, and Thyssenkrupp, at least in Europe, is very well known for steel business. But when we talk about the businesses of Thyssenkrupp, Thyssenkrupp is definitely no longer a real steel company. Our steel business is only 30% of our business. So when we talk about our other businesses, we are talking about component technologies. So if you drive a reasonable car, there's a very good chance that a number of Thyssenkrupp components is in your car. So we are building car components, automotive components all over the world. Obviously, pretty much in Germany, but last recently in industrial components, 5 factories were opened up in China. We have a number of factories in US. So we're working as well with the American automotive industry. Okay, the second business we are having, and this might be the business you are most familiar with, because I think I'm 100% sure you already did use it. We are in the elevator and escalator business, so in America is our biggest market for that. So we are providing all kinds of elevators and escalators. And you may have read in the newspaper that we last recently announced a real big step forward in that business, the ropeless elevator. So this will definitely put away all the limitations of elevator, so because obviously the current elevators are limited in height, because sooner or later the rope becomes so heavy that the rope is no longer able to carry its own weight. When you have no rope, obviously this goes away, and the rope forces us to always go vertical. And when you are working ropeless, you can go vertical and horizontal. That's exactly what we plan to do. So we plan to have a solution which is a vertical solution and a horizontal solution. And this basically gives architects a totally new freedom of design. And we are using linear motor technology, which my company developed like 30 years ago for a train which was called Transrapid, which was a magnetic elevated train and was propelled with linear technology. Unfortunately, the breakthrough of technology did not really happen. I think we have one system up and running in China, which is still running very well, with better performance, by the way, than all the rail-guided systems, for a simple reason. It's magnetically elevated, it's driven by a linear motor. That means there are basically no moving parts. And for that reason, obviously, when you have no moving parts and you control the software and the electrical system, then you're basically doing very well. So the performance, meaning the uptime of the system, is much higher than the systems with mechanical parts. So let's give it another try. Okay, I was talking about Thyssenkrupp. I think we have industrial solutions, which is a business where we basically provide all kinds of engineering solutions for our customers, material services, and I talked about steel. And what I intend to talk about is, on one hand, the organization Industry 4.0, but on the other hand, I will intend to talk about the transformation of Thyssenkrupp, because our vision is to make Thyssenkrupp, which for many people is a more hardware-oriented company, in a digital enterprise. And this is part of the transformation we are doing in Thyssenkrupp, because I believe, and my CEO believes, that it's extremely important that basically you optimize your business to be successful over the next decades. And this is exactly what we intend to do. The differentiation of Thyssenkrupp is obviously not, we are not the cheapest because we are headquartered in Germany. We have a lot of activities in countries like United States, but as well in Asia. So our differentiation has to be innovation and technology. And for that reason, we say our differentiation is engineering, and the German word for engineering is Ingenieurkunst. And this is basically what we're using to promote our technology. And we are strong in German engineering in plants, materials, mechanical and mechatronical systems. And if you want to be successful again, you have to solve a problem. And the problems we identified were demographic change, urbanization, globalization, but there are as well limitations, and this climate change, limited resources in the political framework. And so our idea is to sell on one hand more products to our customers based on the demand, which is created by many of those drivers, but as well better product which basically meets those limitations. And as I'm responsible in Thyssenkrupp, and this is now part of my personal introduction for sustainability, innovation and technology, I always say we have to have a sustainable innovation strategy, because there is no innovation without sustainability in future. And from my point of view, there is no sustainability without innovation. So we have to create new things. We strive for leading technology, but as well we create sustainable products and solutions for our customers and produce them in a sustainable way. And this, we have a system optimum in mind versus local optima. And this is closely related to my statement, we would like to be a digital company. And obviously our differentiation is resource efficiency. And when we talk about resources, we specifically talk about energy, materials, but many more. And when we talk about we are efficient, we clearly look at the whole product life cycle. Because if you only address one part of the life cycle, you basically can prove everything. But the real truth you learn when you basically start at the beginning of in the beginning is the first idea, when you have an idea what kind of a product or solution you want to sell, and basically it ends with the end of life of a product, or when you basically say, I'll stop the business with that product. And this is basically the life cycle we have to look at if we say, yes, we are sustainable. And when I talk about sustainable, I would like to define the definition, or what I mean by sustainable. Obviously, you have to be sustainable. That have to be profitable, because if you're not profitable, you're no longer around as a company. You have to be social, because if your solutions are not accepted, you won't sell anything in the long run. And obviously, you have to protect the environment. And this basically, in our definition, forms sustainability. And this, by the way, forms the logo of our company. And so I talked about engineering as a very important differentiation of Thyssenkrupp. And the second element we would like to differentiate with is digital world, digitalization of Thyssenkrupp. And this is exactly Industry 4.0. And this is now what I would like to talk about. I think what we are doing pretty much, and this is the topic platform Industry 4.0, and I'm a part of the board, a board member of the platform. You see a number of those companies participating, and it's basically the list of the who is who of the global industry. We have not only German and European companies, we have as well IBM, for example, on board. And this is a picture with the German Chancellor Merkel. And basically, yes, we are very well recognized by politics in the moment. Politics is really discussing how they are able to support us much better. So we are talking to a number of politicians now, how they can support the activity, which was, as I said earlier, initiated by Industrie. And when we talk about Industry 4.0, many terms come into mind. So we talk about Internet of Things, where basically globally it's mentioned, but with as well big data is a big discussion there. Digital factory, security is addressed 2 or 3 rooms next to this room. We are talking about real time, we are talking about efficiency. So all those terms are right, and what we try to do is basically to summarize it under the term Industry 4.0. And from my point of view, the technology for Industry 4.0 is available. So it's not a research project anymore. So all of you know that we have embedded systems. We started with systems with one controller, like a washing machine. Then since many years we're building cars with up to 80 controllers and three bus networks, basically, which is a system of things and a system of embedded systems. And then a car is driving in the natural environment, and more we have car-to-car communication, car-to-infrastructure communication. That means we are really working in a cyber-physical system, and this is basically the environment and the technology we need for Industry 4.0. The other thing is basically communication. We have the cloud. Cloud is available. Cloud services are available. Internet-based services are available. We have peer-to-peer communication. And this is basically the other element we need for Industry 4.0. So when people say, yes, we have to wait to start to work on Industry 4.0, from my point of view, they are totally wrong. We can start now, implementing now. That is the important message I would like to send. And you don't need to read that. That is basically the definition of Internet 4.0, and I give you a short explanation. What are the three elements we defined in Industry 4.0? And what we would like to do is basically, and I said that earlier, we would like to address the whole life cycle. So we are not looking at optimizing one element of the life cycle. We know we have to discuss the full product life cycle, and we have to really to create a value, economically value added in that life cycle. The other element is basically all information available in real time. Because if you want to optimize the system, you basically have to have all the information on hand when they happen, when they appear. And the third element, from my point of view, is really networking, combining people, objects, systems, everything. So it's basically everything is connected and everything can create value together. Those are the three elements: product life cycle, real-time communication, and the idea and the vision of networking. And we talk about the fourth industrial revolution. As Thyssenkrupp is a 200-year-old company, I can show you all the elements of the four or the three earlier revolutions with Thyssenkrupp examples. So the first industrial revolution from our point of view was the steam hammer, basically steam technology, and this really gave us a lot of force, so we could produce a lot of more things in shorter time. And obviously this is something where you see, and this is a steel hammer as it was produced or used by Thyssenkrupp in 1861. The second element is basically optimizing production. It's basically a Taylorism. In America, we always use the production of the Ford T model. In Thyssenkrupp, we basically were producing in a very similar way a grass mower, and this is a plant in the 1930s in Germany. And the third element, the third revolution, was automation, and a good showcase, a good example for automation is a robot. This is a robot produced by Thyssenkrupp in the 1980s. We are no longer in that business, but we still use robots quite a bit. And now we are basically in the fourth industrial revolution, and this is really collaboration, and it described what we're doing. When a revolution happens, there has to be a reason. And so there has to be something, there has to be a paradigm shift. What was a paradigm shift of the first industrial revolution? It was obviously we could produce much more. If you look into the production of iron in 1780, it was 100,000 tons. In 107, it was basically 5.8 million tons. So the differentiation was we could produce much more, basically at the same cost. The second element now was being faster. When you look at the assembly of the famous 4T model in 1913, it took 12 hours and 30 minutes. In 1914, with a different organization of manufacturing with Taylorism, it basically took only 1 hour and 33 minutes. So there was a clear reason, there was a clear driver for the success. And when we talk about automation, again, I use the example of the robot. In 1961, we basically had the first robot, and 1 unit basically had the value of 7,800 work hours. In 2012, we had 1,800 robots, or no, 160,000 units, but and basically the working hours, it was basically a value of 1,800 working hours. So we had many more units, and the units were much cheaper, so it's much more efficient to work with robots and replace human work with work by robots. And now the clear question is, if we believe that Industry 4.0 or Internet of Things will be successful, what is the success factor for that? That's now the clear question we have to answer, otherwise we shouldn't do it. And as I work for Thyssenkrupp, obviously I defined the objective in Thyssenkrupp. What we would like to do is basically we would like to react more flexible on our customer requests. We would like to reduce our cost. We would like to increase quality. We like increase throughput and reduce our environmental footprint. This sounds a little like the best of everything. So we have to be very careful when we make those claims. But as I go through my presentation, I try to help you to understand why I believe that those objectives are realistic. They will not be implemented overnight, that's very clear, so we have to spend some time on it. But as I said earlier, we have to start now. But there's one precondition, and this is from my point of view, trust and security. Because what we are doing is basically we're opening up all our shop floors, we're opening up all our factories. We have access to all information we have in our company. And that means we have to find ways to protect it. And again, 3 rooms to the other side, there is a discussion about cybersecurity and all the problems we have with cybersecurity. So cybersecurity is definitely a precondition. And the other precondition is basically trust, which is on one hand pretty closely connected to cybersecurity, but on the other hand, if you work very open with partners and basically share everything with partners, there has to be a trusted relationship as well with the partners. So trust and security are preconditions for Industry 4.0. And being here in the United States and coming and living in Germany, basically I would like to give you an example that not only the United States and Germany are working on Industry 4.0, so we had a lot of discussions already with people from China, what they're doing, and basically what China is doing is basically they work pretty much on Internet of Things as well. They have a national center in Wuxi, and I was personally able to visit the center 5 years ago, though this is not for China not new. It's really something they're doing since some time in industry, and now they are working in Chongqing City as well, on the broader term of Internet of Things, and this is basically pretty close to the American definition as well, where we not only talk about industrial activities, we talk about Internet of cars, smart communication, smart home, wearable devices, mobile devices, and China is really pretty much investing into simulation technology. And when you basically talk to the Chinese government, you know that they are very much relying on science, on simulation done by scientists. So they make pretty much decisions based on science. And sometimes, to be honest, I would like to have the Western politicians look into science and science-based decisions much more than they do. But I don't want to live in China for others for different reasons, and you know exactly what I'm talking about. But at least the relationship between universities, science, and the government, from my point of view, helps. And this will definitely help as well the implementation of Industry 4.0. So we have to be careful. Neither in America nor in Europe we are on our own. Industry 4.0 or Internet of Things is a global movement, and all the countries globally will be able to leverage the benefits. So that's, from my point of view, a given. And when we talk about standardization, and I think that will be a discussion here as well today, then we have to have a global standardization. There will be no local standardization anymore. Now I would like to say, okay, we in Thyssenkrupp intend to implement Industry 4.0, and I would like to show you how we do it, and this basically describes as well the features and the functions of Industry 4.0. From our point of view, it has 3 elements. It is vertical integration, horizontal integration, and integration across the life cycle. That's basically what we're doing. And I would like to start explaining the vertical integration. And this is pretty much looking like an old-fashioned implementation. We have an ERP system, MES, we have Smart Factory, and you are right, this is basically what we did since many years. But on one hand, now we really have to do it more consequent, really allow all the data going top-down and bottom-up. And on the other hand, there's no longer need to implement it in a hierarchical way. Basically, now we really can implement it as a grid. So it's moving on one hand into a grid, and on one hand, other hand, we really have a good chance to make it more efficient and really use it as it's intended. The other element is basically the communication between machines, the communication between factories, the communication between vendors, suppliers, customers, though there should be all kinds of horizontal integration. And to show you some examples, I think that's something we really are either we already implemented or we are in the process of implementing. And I start with a small thing, so basically elements of a machine talk to each other. So in the history, we basically had a machine doing the machining, and in the next step, we were measuring how accurate the machining was. Today, we obviously have the opportunity with a lot of sensors to measure during the machining, during the manufacturing process. So there's a close communication, a close link between the machine control and the sensors, and so we reduce the number of production steps because we have an integrated solution for process measurement. The next step is basically communication machine to machine, and this is an example of our automotive components business, where we basically build and assemble camshafts, the motor control elements basically. Those camshafts are assembled, they are then measured, and then in a third step and corrected, and the assembly is corrected in a third step. They're really going through a lathe. And when we basically give the individual workpiece each the data of the previous step, we basically can definitely optimize the production process in the next step. So we basically, all data are going with the workpiece through the production. And this is basically now really the connection, the networking machine to machine we are describing here. And this is implemented in our factory in Germany, not too far from Wolfsburg, the Volkswagen factory, where obviously now guess who is our customer. The other element is basically a factory in a very nice area of Germany, the Sauerland, and here you see the factory in a very narrow valley. And this factory is producing as well automotive components. This is a cold rolling activity, which is basically producing metal parts as well for the automotive industry. But there's one issue. If you would like to increase production, we have to make it more efficient because it's located in a very narrow valley and there's no additional space for us. So obviously either we cannot increase our production or we have to increase throughput and efficiency. And this is basically the idea what we would like to do with Internet of Things and with Industry 4.0. So obviously we already optimized our production, and the production is that we get a slab and we reload the slab, and then eventually customers get a coil. This is basically the production. But there are processes which are coming earlier. We get the slab from a blast furnace in Huckingen, which is close to Duisburg. And obviously we have customers which order the slab. And the idea is basically to integrate exactly this supply chain. So the customer is basically telling us when he needs the product. So we allow the customer to give us data directly into our system. So our customer sees as well how many orders we have in our system, so he knows when to order to get it on time. So he gets a prediction on time. He gives us all the data necessary for his product, and we immediately transfer the data as well to our provider of the slabs, the slab casting factory in Huckingen. And now the customer tells us, okay, now start the production. So the customer tells us, now I need it in maybe 3 days, and then we start the whole activity. The slab is cast or is taken from a store in Huckingen. It's transported via rail to Hohenlimburg, the location of the factory, and we already know in Duisburg basically exactly what kind of slab is it. So we have a slab identified. We know exactly where it's located in Duisburg. We know exactly where it's on the car of the train. We know what slab is on top. We know what slab is below. Then we basically unload the car in Hohenlimburg. Then we have a very small storage in Hohenlimburg. We know exactly where the slab is. It's 100% identified. It's put by a crane into production. We know exactly what kind of coil is produced out of the slab, and at the end of the day, the coil is immediately shipped to the customer. So we basically have a 100% efficient supply chain between us and our customer and our supplier. So this is only possible with Industry 4.0, where basically that everything is connected. And I mentioned earlier trust. So obviously our customer trusts us by giving us all the information. We trust our customer and our partners that basically the information we are sharing is not misused. And obviously cybersecurity in this case is another very important feature. So this is basically the horizontal integration. And now the third element I wanted to describe is the integration over the PLM cycle. So in Thyssenkrupp we defined a PLM life cycle over the entire product world, and this is not rocket science. I think you can read it in many books today. The life cycle starts basically with the innovation process. First you have to have an idea, you have to scout ideas, you have to select ideas, you have to have an ideation process, and obviously we have the production and use process. We introduced milestones and quality gates, and then KPIs obviously as well. And then we say not everything is linear, so we have loops as well in our system. This is basically the definition we use in Thyssenkrupp as a product lifecycle definition. And I think there's a first step. The idea creation, ideation, scouting, selection of the ideas. So we have a very clear definition how we select ideas. We try to get ideas where we can get it. So open innovation is extremely important to us. We get it from universities, research institutes, customers, other partners. So we are very open to all kinds of innovation and ideas. Then we check in our portfolio management, does this idea really fit to Thyssenkrupp? Do we have the technologies available, or do we believe we can learn those technologies? And is there a market? I think obviously to have a new product, a new solution, a new service, you have to have a market. And when you have a market, obviously you have customers. And when you have customers, you should definitely understand what the customer's requirements are, because it's extremely important to clearly understand customers' requirements. There's nothing is more expensive than implementing something a customer is not ready to pay for. So for that reason, customer requirements is an extremely important topic for us. After we clearly have checked everything, so it's as a market, there are customers, we understand the customer requirements, then we can develop the product. And obviously here we as well use a clear defined product development process. We use lean innovation, as already we start to use lean innovation, and we obviously make design to cost activities. After development, we can give the idea, the product developed into manufacturing, or we give it into engineering, because obviously Thyssenkrupp on one hand is building product, but on the other hand we are doing systems and solutions and so or services, and this is obviously then engineered. To optimize this, we work with virtual commissioning. So before a system is implemented at the customer side, we implement it or commission it virtually, so we can test it already virtually before we go to the customer. And this is basically the environment we are using in this virtual commission activities, and this is what our organization system engineering, which is part of our industrial solution business, does. And now basically we are in the phase of product life, which from our point of view is an extremely important phase as well, because obviously we are not only in the business of selling solutions, products and services. We do services on our products and solutions as well, and for that reason service business is an extremely important part of our business, and specifically in elevator business, service is extremely important. And here again, Industry 4.0 comes into play, where we basically say, yes, we have a clear communication between our service people, our headquarter organization, and we can as well talk to the machines basically. And eventually we are talking about the end of life, and the other thing, end of life is a very important topic for me as well, because you have to think about recycling. I talked earlier about sustainability and resource problems. So we definitely have to think about what happens to the product after the end of life. And obviously, when you think about it at the real end of life, it's too late. So you have to think of defining end of life is already a requirement in requirements engineering and has to be taken in consideration during development time. And on the other hand, there has to be a commercial phase out as well, planned obsolescence. that means we have to plan as well when are we no longer supporting those products, because products supported unnecessarily is a very important, costly activity as well. So, but another element from our point of view, which is extremely important, is the human being. So the idea is not to replace human beings. The idea is to get a better support for the human beings. And on one hand, we would like to help human beings, people, allow and support them to make more informed decisions. But on the other hand, we would like to help them physically with handling support through robots. But this really means that we need better educated people. So I think not every worker today is able to cooperate with a robot. Not every worker today is really able to use all the information which we will be able to provide him through Industry 4.0. And another element from my point of view is extremely important. This is part of our service activities. That's data analytics. During all these activities, we are producing a huge amount of data. And in the moment, we are not using those data as efficient as we would like to. And this is a project we started together with Microsoft some months ago. And this will be implemented in our data centers and support centers all over the globe. This is an elevator support center in South Korea, Seoul, South Korea. And the idea is basically that we get all the information about elevators up front. We connect what we call a blue box to any elevator, and this basically allows us to have access to all the information of all the elevators up front. So on one hand, we will be able to do predictive maintenance, so we go to the elevator before it breaks. But on the other hand, when we go to the elevator, we know exactly what kind of spare parts we have to do. We know exactly what kind of information the people have to have, because everybody is known up front. So this is another very important step to make our business more efficient, and obviously integration and networking is here very, very helpful and important. The other thing is basically human-machine interoperation, and I think today, specifically in automotive plants, robots are fenced in, because obviously if they hurt people, that's very, very risky. So normally robots work in a fenced environment, and if men have to interfere, they have to open a door, the robot stops, and basically, but this is really costing us a lot of efficiency. With better sensors, a robot can basically understand what a human being is doing. And so the idea is basically, and we have first discussions with a partner of us, that we say basically, why don't we have create interoperability between people and robots? It means on one hand, robots are recognizing what people are doing, so they will stop if people are coming into their way. But on the other hand, basically, if people are hit, the robots have sensors and they basically stop immediately. So it's safety is taken care of. And this is something, from my point of view, which will allow people to work longer in life. We're talking about an aging population, so I think hard work is no longer possible when you're older. But with the help of robots, obviously, you can stay longer, even in challenging jobs. With this, I would like to summarize. So I think it will not happen overnight. I think this is something, specifically if we talk about a company like Thyssenkrupp, 160,000 employees in basically 60, 70 countries all over the world. You don't change a company like that overnight, because we were talking as well about a culture change. It's not only implementing technology, it's really changing people, educating people. It's really creating a culture change. But the benefits from my point of view are worth it. It's basically reduction of cost, higher flexibility, improved quality. And the idea is really don't wait. We need to start implementation now. Thank you very much.